Hello dear followers of Mwalimu Theophil Academy, welcome to this session. Today I have prepared you a lesson of top 5 questions basing on Newton's second law of motion. These questions are of different concepts, but through those 5 questions I am sure that you are going to cover each and everything concerned with the calculations from Newton's second law of motion. Now let's start. The first question, it states that what force is required to accelerate a 5 kilogram object at 2 meters per second square? Let's see the solution for this. In this question we are given mass m is equal to 5 kilogram. Acceleration a is equal to 2 meters per second square. But you ask the force. Force F is equal to how much? From Newton's second law of motion, we know that force is equal to mass times acceleration. So here we already have mass and acceleration. Now our force will be equal to 5 kilogram times 2 meters per second square. 5 times 2, we get 10, as it is force will be Newton. Now, the force required is equal to 10 Newton. After that, let's go to a second example. The second example states that what mass of an object will require a net force of 40 Newton to accelerate at 5 meters per second square. Now, let's see the solution. In this, we already have force F, which is equal to 40 Newton. Also, we have acceleration A, which is equal to 5 meters per second square. Now we are asked the mass. From Newton's second law of motion, we are told that force is equal to mass times acceleration. To get mass, mass will be equal to force divided by acceleration. Now mass will be equal to force over acceleration. This will be equal to, force we have is 40 Newton, divided by an acceleration which is 5 meters per second square. 40 divided by 5, we get 8. Now the mass will be 8 kilogram. This is the answer. Before I go solving a third example, remember that I have said I have come today with the 5 different concepts on various calculations involving Newton's second law of motion. So don't get tired, you are going to see a third concept. A third example states that find the acceleration of a 2 kilogram mass if a force of 8 Newton is applied. Before I solve this, I remind you, first subscribe. I am waiting, just subscribe and hit the notification bell so as to get updates when we upload any video in our channel. Just subscribe, I am waiting. Have you done it? Yes, that is nice. Let's go ahead. The solution for this, in this question we are given mass is equal to 2 kilogram. Also we are given force F is equal to 8 Newton. And we are asking you to calculate acceleration. As we've done in the previous 2 examples, now again we use Newton's second law of motion, and from it we say that force is equal to the product of mass and the acceleration. Now we are asking the acceleration. To get this acceleration, we take force divided by mass. Our acceleration is equal to force over mass. The force we have here is 8 Newton divided by mass, which is 2 kilogram. 8 divided by 2, we get 4 meters per second square. Now the acceleration will be 4 meters per second square. After that, let's go to our fourth example. This is our fourth example. But before we solve it, I remind you that by the end of this session, we're going to have a quiz. So make sure that you do it. Okay, now let's go ahead. Our fourth question states that what force is needed to keep a 10 kilogram object stationed on a frictionless surface? Let's see the solution. In this question, the data present, we have mass of an object, which is 10 kilogram, acceleration A. For the case of acceleration, we are told that this object is stationed on a frictionless surface. It means that it is not in motion and there's no any friction on the surface where it rests. So it means that its acceleration is 0. But you are required to calculate force. Now what will be the force? As usual, according to Newton's second law of motion, we say that force is equal to mass times acceleration. Now the force asked here will be equal to mass times acceleration, 10 kilogram times 0 meters per second square, which is the acceleration. Now this will be 0. So the net force needed is 0, meaning that there will be no any net force required because an object is stationary resting on a frictionless surface. After that, let's go to the last example, which is example number 5. The fifth example states that a car of mass of 1,000 kilogram accelerates at 3 meters per second square. What is the net force acting on it? The solution. Here we are given mass and the acceleration. Mass we are given 1,000 kilogram. And the acceleration we are given 3 meters per second square. What is asked here is net force. But we have said that according to Newton's second law of motion, net force F is equal to mass times acceleration. Now, our net force here will be equal to 1,000 kilogram times 3 meters per second square. When we take 1,000 times 3, we get 3,000 Newton. Now, the net force acting on this car will be 3,000 Newton. Thank you for attending this session. But remember that we have a quiz. And our today's quiz is you to state 2 units of acceleration. What are the 2 units of acceleration? Comment below.